Hello, in this video we're going to work through sheet 4 number 1. I'm happy to put all sorts of video solutions on here, and I'm happy to provide them for both my students and those of you that aren't my students. So please feel free to ask questions. I love making these really help me improve my teaching techniques. But what I want to do is I want you to pause here for a second, and if you haven't tried this problem, I want you to stop and try it. It's really important you try a problem before you watch the video. It's one thing to follow through a solution, it's another thing to get it on your own. So try it, even if you don't get it. Give it a try and then come back and watch this. Okay? Wonderful. So let's dive in. The first thing I'm going to do here is I'm going to draw a picture, because I always draw a picture. So you'll notice here, as I've actually gone in the problem and called this point A and called this point B, and that's going to help in terms of me talking about this problem. So let's call this 1, 1, or sorry, it's called A, 1, 1, and 3, negative 3. Let's call this point B. There we go. So now I need to find a point on the x-axis, which is an equidistance, and that's a really important term there, on the x-axis. And the reason why that's so important is because if it's on the x-axis, and let's call our answer point C, what that means is that the y value has to be 0, and that means I've reduced one of the unknowns in this problem. So what I can do now is I can draw a diagram. I don't know where this is going to be on the x-axis. I'm just going to put a point just as an educated guess. So I'm going to guess it's somewhere around here. I don't know if that's the case, but we're going to guess. So the word that jumps out on here is same distance. So we're talking about distances. We want to show that the distance of this line is equal to the distance of this line. Okay, so if we want to do that, we're going to use the distance formula. So let's call this distance A, and we'll call this distance B. And actually, no, I'm going to reverse this. I'm going to call this distance B and this distance A. And that's in part because if I imagine this being a triangle, then this would be side B. So what we know is that B is equal to the square root of 1 minus x plus, that's squared, plus 1 minus 0 squared. Okay, and we know that A is equal to the square root of 3 minus x, and then plus, squared, minus 3 minus 0 squared. So now I can do now what I can do is I can take these, and since A and B are the same, I can say that the square root of 1 minus x squared plus 1 minus 0 squared is equal to the square root of 3 minus x squared plus minus 3 minus 0 squared. So now I have some algebra I can work through. So what I'll do is I'm going to square both sides. So I'll have 1 minus x squared plus, and now I'm just going to, 1 squared is 1 equals 3 minus x squared plus negative 3 squared is 9. So now I'll have to expand these binomials. So we're going to end up with 1 minus 2x plus x squared plus 1 is equal to 9 minus 6x plus x squared plus 9. So I've simply done a binomial expansion. Maybe for those of you that are just unclear on that, let's just do this up here. 1 minus x squared is equal to 1 minus x times 1 minus x. So 1 times 1 is 1. We take everything in the first bracket, multiply by everything in the second bracket. 1 times minus x is minus x. Minus x times 1 is minus x. Minus x times minus x is plus x squared. So therefore we get 1 minus 2x plus x squared. Now you'll notice I've left it in brackets. I do that in part from habit, because sometimes in the algebra, if there's a negative sign out in front here, then I remember to multiply that into all the terms. But we'll see some other examples of that later. Oh, I just lost my axes. That's okay. All right, so now I'm going to do some simplification. And again, just to pause a second, my initial gut reaction here is to say, oh my gosh, I have these x squared. really important is don't give up. Often students and adults will see something and they'll stop and they'll say, "Oh, I don't know what to do." But you know, something I always think would math is just like a puzzle. You just got to keep working away at it, and sometimes things will just work out in your favor. So in this case, something does work out very nicely for us. So let's just rearrange the left-hand side, and we're just going to clean it up a little bit just before we see what works out nicely. X plus 2 equals x squared minus 6x plus 18. And look what works out really nicely here. If I have x squared on this side and x squared on this side, I could subtract x squared from one side and they cancel each other out. And that's great now, because now this is easy to solve. If I gave someone this, I would feel really easy. That's not that much of a problem. So if we rearrange this, I'm going to get, oh, forgot my x. So we're going to get 4x if I add 6x to both sides. And then equals 16. So x is equal to 4. And let's draw these axes in again just to make sure. I think it's something like that. There we go. That seems about right. So it's telling me that x is 4. So the answer to this problem is 1, 2, 3, 4 is right here. So my diagram was wrong, yes. But I had the right idea. And take a look at this. Over 1, up 1, 2, 3, down 1, 1, 2, 3. This is the type of problem with a little bit of closer inspection you probably could have gotten the answer from the diagram. But this algebra is what is so key in your development. So again, just to sum up really key points from this. The first thing, like always, draw a picture. If you don't know where the point is, guess. The fact that the point is on the x-axis tells us something very important for this problem and many more problems to come. And if it's on the x-axis, that means the y value is 0. If you don't make this observation, you cannot finish this problem. So I want you to really kind of put that into your bag of tricks. If a problem says it's on the x-axis or y-axis, think about what the y or x term is, relatively speaking. So if it's on the x-axis, the y value is 0. If it's on the y-axis, the x value is 0. The next thing that's really big in this problem is the word the same distance. So that means we're going to find two distance formulas and set them equal to each other. So that's what we did right here. And then notice if we have the square root of both sides, we can take the inverse operation of that, which is square. So we square both sides to get rid of it. And then we get to this point here. This is the point where people usually get really nervous, and a lot of students will stop and say, "That's it. Nope, can't go on from there." However, notice with just a little bit of moving forward with this, you'll actually end up canceling out those x squares and being able to work out a nice answer. Anyways, I hope this video helped.